So we continue with the periodic table and we are on the Moseley's classification. So basis of classification of the elements in case of Moseley was the first thing and the most important difference what Moseley did in case of the change is Moseley converted the periodicity of the periodic properties of the elements as not as a periodic atomic weight, but he took it with respect to atomic number. So atomic number changed the game completely. Okay, so most of the defects of Mendeleev's periodic table disappear if the basis of classification element is changed from atomic weight to atomic number. Till the time we are keeping it atomic weight, all the problems of Mendeleev's periodic table are there, which can be highlighted easily. But the moment we convert it into atomic weight के बदले atomic number, most of the things like cobalt and nickel का जो problem था वो automatically solved out हो जाता है, because cobalt has got a higher mass than that of nickel, but cobalt has got a lower atomic number than nickel. That's why cobalt will come first and nickel will come next in the periodic table. So Moseley arranged elements in increasing order of the atomic numbers in 7 horizontal rows called periods and 18 vertical columns called groups. This form is the basic of the modern periodic table. So what it has got, the modern periodic table, what it has got is, first thing, it is based on the atomic number. The second thing is that the number of groups what are there are 18. There are 18 groups, and the number of rows, that is nothing but the periods what are there. The periods are going to be 7. So 7 periods and 18 groups. So the total number of groups and the total number of groups are 18 and the total number of periods are 7 in the modern periodic table. This forms the basis of the modern periodic table. Modern periodic law, so he changed the modern periodic law that the physical and the chemical properties of the elements are periodic function of their atomic number. So the periodic functions जो भी है, it is because of the atomic number and no longer the atomic weights. Hence, elements, if arranged in increasing order of atomic number, showed similarity in properties after regular intervals. This is termed as periodicity in properties. So, the periodicity properties was easily seen when the elements are arranged in the atomic numbers. Moreover, it's quite easier also because we know that atomic number से हम लोग electronic configuration मिलेगा. Electronic configuration से हम लोग को मिलेगा कि उसका valency कितना है. Elements having similar valence, same valency will be similar in characteristics. So automatically grouping them together became more easier. And the periods told you which are the different shells. As the period changes, there is an increase in the shell in that particular element. So the shells also are going to change. Hence, so the reason for periodicity in properties, after definite interval of atomic number, recurrence of similar electronic configuration takes place. सबसे पहले में 1. Next one will be 2,1. Next one will be 2,8,1. Next 2,8,8,1. No? So you will always find that there is a continuous recurrence of a similar kind of electronic configuration in a particular group. Since properties of the elements are dependent on the number and arrangement of electrons, including electrons in the valence shell, elements having similar electronic configuration have similar properties. So those who got similar electronic configuration will have similar properties that could easily be identified. So periodic properties include, first one is atomic radius. So what are the different periodic properties which were found to be of similar nature? The first one is atomic radius. What is atomic radius? It is the distance between the center of the nucleus to the outermost shell. So distance between the center of the nucleus and the outermost shell is the atomic radius. Second is ionization potential. Amount of energy required to remove an electron from the outermost shell of an isolated atom. So, if there is an atom, वो atom के अंदर एक 1 या 2 electrons, valence electrons है outermost shell में, उसको निकालने के लिए the amount of energy required to remove an electron from the outermost shell of an atom is called as the ionization potential. So the amount of energy required to remove an electron from the outermost shell of an isolated atom is called as an ionization potential. The third is electron affinity. The amount of energy released when an atom in a gaseous state accepts an electron to form an anion. So जैसे वहाँ पे इलेक्ट्रॉन निकाला वैसे कोई ना कोई, जैसे सोडियम के अंदर से हम लोग के आयनाइजेशन पोटेंशियल कम रहेगा, that you can easily withdraw, remove an electron from sodium. Whereas in case of chlorine, what will happen in chlorine? It is going to accept an electron. The chlorine is going to accept an electron. When it accepts an electron, it is going to release a certain amount of energy. So to accept an electron, it releases the energy. The amount of energy released by an atom to accept an electron to form into an ion. Okay, what is an anion? A negatively charged ion. So एक इलेक्ट्रॉन को एक्सेप्ट करेगा तो वो एनायन बन जाएगा. तो वो इलेक्ट्रॉन एक्सेप्ट करने के लिए जितना एनर्जी वो रिलीज करेगा, दैट इज नथिंग बट द इलेक्ट्रॉन एफिनिटी. You are going to learn this in detail when you are going in the 10th standard. Right now you can just learn this as the definitions which are here. Some salient features of the modern periodic table are: first one, arrangement. Arranges elements in increasing order of atomic numbers in 7 horizontal rows called periods and 18 vertical columns called groups. Then what are periods? Each period begins with an element having one electron in the outermost shell and ends with a completely filled outermost shell element. So when you see a period starts with having one electron in the outermost shell and then 2 electrons, 3 electrons, 4 electrons, 5. And the end of the period, you will find that at the end of the period, the element will have a complete octet. Okay, the octet or duplet what is there is going to be complete. So it starts with 1 electron and ends with 8 electrons in the outermost shell. So that's how the periods के अंदर क्या होगा कि each period will begin with an element having 1 electron in the outermost shell and ends with completely filled outermost shell across a period in a transition from metallic to non-metallic characters. So because we know that metals are the one which are going to give away electrons, so valency will be 1, 2, 3 plus 1, 2, 3 यानी metals. उसके बाद 4 and then -3, -2, -1 and 0. So that will be non-metals. So that's why a transition from left to right in a periodic table will be such that it is here in the left hand side it is more metallic, and towards the right the metallicity decreases and that it becomes more non-metallic. In the groups, the group 1 and group 2 are reactive metals. Group 1 and group 2 are highly reactive metals. The 3 to 12 are the transition elements or metals which are transition elements. These transition elements are the one which normally have variable valency. So the transition elements are normally there only from the period number 4. In the period number 1, 2 and 3 there are no transition elements. So there are no elements in the group number 2 to 13 in the first 2 periods. In the first 2 periods there are no, in the first 3 periods in fact. In the first 3 periods there are no elements in group 3 to 13. Group 12, sorry. Group 3 to 12. 13 to 17 contain non-metals in the upper right corner. So from group number 13 to group number 17 will be non-metals, and group number 18 is for inert gases, that is noble gases or inert gases. So this is the periodic table. You can see this is the periodic table. So this periodic table has got 18 groups. So these are the 18 groups, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ऐसे करके यहाँ तक 18 तक. So these are the groups and these are the periods. So you can see 7 periods are there, 1, 2, 3, 4, 5, 6, 7. So you can see the 1, 2 and 3 के अंदर ये part में कोई भी कुछ भी नहीं है. It is only from the 4th period that you are having elements in this 3 to 12. In 3 to 12 the transition elements are there. These are the transition elements. So you can see that the first 2 are reactive metals. Over here first two are the reactive metals. Over here these are the transition elements. These are the non-metals and this is the inert gas. Okay, these are the actinides and lanthanides, lanthanides and actinides which are there below, which we will study later. Okay. Now, so let's see in detail about the periods and the groups. So what is there in the period? What is there in the group? What are the different periods? So period and the period number. Periods, 7 horizontal rows of elements arranged in increasing order of atomic number. So there are 7 periods. There are 7 horizontal rows in the periodic table wherein the elements are arranged in increasing order of their atomic numbers. So period number are period 1, 2, 3, 4, 5, 6 and 7 signifies. And what does it signify? What does the period number tell you? It tells you the number of shells the particular element has got. So if I say that one particular element is in period number 5, that means it has got K, L, M, N, O. These 5 shells will be there inside. If I say that a period, element is in period number 2, that it has got only K and L shell. It doesn't have any other shell, it's got only K and L. Okay, so the period number tells you the number of shells present in an atom. The number of shells present in an atom is going to be determined by the period number of that particular element. The first 3 periods of period number. So period 1 elements are hydrogen, that has got only 1 shell. Then it is period 2, example lithium, which has got 2 shell, L and N, so 2, 1. Period number 3 is element is sodium, so 11, so it is 3 shells, the 2, 8, 1. So you can see that this way, the first one has got only 1 shell, second has got 2 shells, 2, 1, third has got 2, 8, 1. The first 3 periods of the modern period table are, first one is called as the short period, or you can say the shortest period, because it has got only 2 elements. The period table first row of the period table, that is the first period of the period table, has got only 2 elements, and those elements are the first period has got only 2, which is hydrogen and helium. Okay, hydrogen is in group 1 and helium in group 18. The next come is the second and the third one. They are short periods and they both have got 8 atoms each, 8 elements each. Okay, the third one, that is from lithium to neon, and the last is sodium to argon. Okay, so it is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon in the period number 2, which is a short period having 8 elements, and third period also has got 8 elements, that is from sodium, so to put sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Of course, the electronic configuration will be 2, 1. In case of the second period will be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. इसलिए क्या रहेगा 2, 8, 1, 2, 8, 2, 2, 8, 3 till 2, 8, 8. So period 1 has got hydrogen in group 1A and helium in group 18. Period 2 has got group 1 में element is lithium, atomic number 3, electronic configuration 2, 1 and metal. It's a metal with valency 1. Similarly, beryllium will be 2, 2, a metal with valency 2. Boron will be again 2, 3, which is a metalloid. It is a combination. It is having the properties of both metal as well as non-metal, so it's called as a metalloid, and it has got valency 3. Carbon is 2, 4, which is a non-metal having valency 4. Nitrogen 2, 5, non-metal valency 3. Oxygen 2, 6. Non-metal valency 2, fluorine, that is F, which is 2, 7, hence valency is 1, and neon is 2, 8, so valency is 0, which is a noble gas. In period 3, we have got first one is sodium with this 11, that is 2, 8, 1, and it's a metal with a valency 1. Magnesium will be 12, which is 2, 8, 2, metal with valency 2. Aluminium again is a metal 2, 8, 3. Metal and valency 3. Silicon is a metalloid and it will be having 2, 8, 4 and valency 4. Phosphorus is 2, 8, 5. It is a non-metal and valency 3. Sulfur is 2, 8, 6. Valency is 2 with being a non-metal. Chlorine 17 is 2, 8, 7 with a valency 1. It's a non-metal. And argon will be 2, 8, 8, which is a noble gas, so valency 0. So the property trends of the elements from left to right is that similarity क्या है? What is the similarity in the properties of the in a particular periodic table? It is seen that the number of electron shells in a period remains the same. So what is the similarity? That the number of electron shells in a particular period remains the same. And another thing is the transition of valency कैसे होगा? So the transition will be from metallic to non-metallic metal. So it increases by 1. So the valence electrons increases by 1 as we move from left to right. So as we move from left to right, the transition will be such that it is going to from metallic to non-metallic, and its valence electrons are increasing by 1. We now talk about the groups. So talking about the groups now. There are 18 vertical columns with 8 main groups in the periodic table. Group number, the group number signifies, now what does the group number signifies? The group number is going to signify the number of electrons in the outermost shell. See, it is this way. If you see the older numbering of the periodic table, it was given as 1A, 2A, 3A, 4A, 5A, और फिर B डाला है, C डाला है, so 2B, 3B. So that is going to tell you. So if you see the periodic table, it is like 1A is 1, 2A is 2, 3B is 3, 4B is 4, 5B is 5, 6B is 6, 7B is 7, 8, 1 has got 8, 9, 10. All 3 has got 8. And then it is 1B as 11th one, 2B as the group 12, and then 3A is 13, 4A is 14, 5A is 15, 6A is 16, 7A is 17, and 0 is 18. So all the A ones are called as the one which are called as representative elements. The A ones, so group A, 1A, 2A, 3A, 4A, they are called representative elements, and there the valence electrons are going to increase with the group number. So the group number of that particular A ones will also give you the number of valence electrons in the element. So the group number signifies the number of valence electrons of the element. So group 1, that is 1A, elements have 1 valency, that is 2, 1. Group 2 elements, that is 2 valency, that is beryllium, that is 2, 2, or magnesium 2, 8, 2. Transition elements also have 2 valency electrons, that is Fe will be 2, 8, 14, 2 and 2, 8, 18, 2 in case of zinc. The groups of the modern periodic table are, first one is, group 1 is alkali metals, that is from lithium to francium. So lithium, potassium, iridium, sodium, potassium, rubidium, cesium and francium are the one which are in group 1. You need to learn this sequence of the first group. So it is lithium, sodium, potassium, rubidium, cesium and francium. This group 2 are alkali earth metals. So they are, see the first one are the alkali metals because they are all alkaline in nature. These are the metals which are going to form into hydroxides when reacting with water. They are soluble in water, that's why they are called as alkali metals. And the next one is again the alkali in nature, but they are slightly lesser reactive, that's why they are called alkali earth metals, that is from beryllium to radon. And the 3rd to 12th are the transition elements, in which there are from scandium to zinc and wire to CD, cadmium. And then there are some in between. In the 6th and the 7th period, there is another group which is called as lanthanides and actinides. So the actinide series from 57 to 80, from 57 to 72, and from 58 to 71, and actinides from 89 to 104. So these are the ones which are lanthanides and actinides which are there. You need not learn this part because it's not required for the 9th standard students to learn it, neither in the 10th standard. 13 to 16 are post transition elements, that is aluminum se chalu hoke Sb, that is Sb is antimony, right? And then Ti to Po. So these are from 81 to 84. They are post transition elements, and that is 13 to 16. And finally, 17th, again very important, which you need to learn again, and that is about halogens. Halogens are for fluorine, fluorine, chlorine, bromine, iodine, and there is also one more which is 80, that is acetylene. Yeah. Now, so in the 18th group is the noble gases. So inert gases or noble gases, which is helium, neon, argon, krypton, xenon, and radon. Okay, so these are the one which are the inert gases. So property terms of the element on moving the group. So how is the property trend going to be there in a group? So when you are taking a one particular group, how do you see the trend? So it will be either from top to bottom or bottom to top. We'll normally take top to bottom. So we see that when you are taking the first group, that is lithium, potassium, sodium, potassium, rubidium, cesium, and francium, the similarity is that all of them will have same valence electrons in them. All of them have valency 1. So in the similarity in a particular group is that the valence electrons are going to remain the same, and hence the chemical properties remain the same, because chemical properties are dependent on the valency of the element. Hence the chemical properties are going to remain the same or vary slightly gradually a bit. So chemical properties are dependent on outermost electron configuration. Outer electron configuration. But what is the transition? The transition is that number of electron shells, that is metallic character, increases down the group. So see, as the shell become bigger and bigger, see number of shells badenge, because we know that period wise the number of shells are going to increase. So one in the group, you can see all the periods are there. So the one which is in the 5th group will definitely have a bigger atomic radius than the second one, because 5th has got 5 orbits, whereas the 2 has got only 2. So accordingly you find that since the size increases, the metallic characteristic also increases, because it is easier to remove an electron from a bigger atom than a smaller one. See, smaller one ke liye kya hoga? The number of electrons and the protons are less, and that's why the force of attraction is less. Right, I'm sorry, the distance is small, so distance is small, that's why to hold that thing together, the nucleus holding that electron together is much more. So it is difficult to remove an electron from the one which are in the upper part of the period of the group. The lower part, because the shell is bigger, because the atom is bigger, so the distance is greater. So वहाँ outermost electrons को निकालना, outermost orbit से electron निकालना easy हो जाता है. That's why you see that the metallic properties are going to increase down the subgroup. Okay, so metallic characters increase down the subgroup, and that is increased by 1. So the increase will be by 1. So that is about the groups and period. We now have the details about the groups of the period. So the main types of groups in the periodic table are group is alkali metals. So elements are lithium, sodium, potassium, rubidium, cesium, and francium. Valence electrons are 1. So valency is univalent. Nature will be highly reactive, electropositive light metals. Reactivity wise, react with water, forming strong alkali. The second group is alkali and earth metal, which is beryllium, magnesium, calcium, strontium, barium, and radium. The properties are similar to the alkali metals. Now group 3 to group 12, that is transition elements, they are all metals. They lie at the center of the periodic table between metals highly electropositive on the left and non-metals highly electronegative to the right. There are inner transition elements, which are lanthanide, rare earths, and actinides series. They lie at the bottom of the periodic table in 2 horizontal rows, 14 elements each. Lanthanide series, that is cerium to lutetium, and actinides from thorium to lawrencium. They are all metals and chemically very reactive. Actinides are reactive. Group 13 to 16 are post-transition elements, that is aluminum to Ti and Ge to Pb and Sbi and Po. They are weak metals and metalloids. Finally, group 17 is halogens. Elements are fluorine, chlorine, bromine, iodine, and acetylene. Nature under research. And valence electrons are 1 valency univalent. Nature will be highly reactive, electronegative, good oxidizing agent, and conduction wise non-conductor of electricity. Group 18 are noble gases, 0 group elements. Elements are helium, neon, argon, krypton. xenon and radon. Reactivity, stable electronic configuration, so unreactive or inert in nature. Higher members form compounds under specific conditions. So the normal elements are the one which are in group 1, 2, 13, 14, 15, 16, 17, 18. Okay, they are the normal elements. So elements in which atoms have all shells complete except outermost incomplete, they consist of metals, metalloids and non-metals. The number of electrons in the outermost shell signifies the group of which they belong. And then there are some which are called as the bridge elements. Now bridge elements ऐसा है कि भले वो अलग अलग ग्रुप में है फिर भी इसका रिलेशनशिप इसके साथ में in the different period and the different group. So adjacent period and adjacent group में there is, so this is 1 year and this is 1 year, which will be the bridge elements. So second and third and the second period elements of the second period show resemblance in properties with elements of the third period of this next group, leading to a diagonal relationship. Such elements are called bridge elements like lithium and magnesium, beryllium and aluminum, and boron and silicon. So these were about the groups and the periods. We are now going to move to the elements and the detailing about the elements in the next video.